This time we're going to create a WebRTC WebSocket application which allows us to create a peer-to-peer connection and send data over a local area network. Welcome back to the channel. Let's get started. So first of all, we're starting with a completely empty Unity project. I'm using Unity 2022.3 and the URP empty template. And first of all, let's remove the README assets and check out the Unity WebRTC package. The link is, as always, in the description box, and WebRTC for Unity allows WebRTC to be used in Unity, and it's widely supported over the last Unity versions. Please note that the WebGL platform is not supported, as well as Windows UWP, and that there are a few settings that must be done when deploying to Android. I'll show that later on in the video. Please note that there is no signaling server attached here, and that you will have to take care of all the networking yourself. First of all, let's install the package. Let's grab the name from the package from the install package section, open the package manager in Unity window, package manager, and click the plus sign in the upper left corner and add package by name. Paste the name, click on add, and after the package is installed, select it, and you see that there is a sample section where you can add the Unity provided samples for WebRTC. Let's have a look at the samples first. So these samples are all created by using your local machine, so there is no networking implemented. Let's start the first data channel example. Click on call. So a peer-to-peer connection is created. Enter text, click on send, and the peer-to-peer connection will send this data to your local machine. And when looking at the data channel sample, you will see that the implementation is basically correct, but it does not work for networking out of the box. So when going down here and when checking all the get name and get other PC methods, you see that this is just a simple if statement for switching, and overall it's a pretty complex sample for something more or less trivial as sending data over the network. So let's switch back to the sample scene, start over from scratch, and first of all we have to make sure that everything is set up correctly. I create a new folder for the scripts. Let's do a little bit of structure before starting. Create a new folder, call it interfaces. Create another folder, right click, create folder, call it models. Another folder, let's call it services. And that's basically the first thing to start. Go into the interfaces folder, create a new C# script and call it iJSON object and open it in Visual Studio. I already implemented the code for the interface iJSON object. Feel free to pause the video here to type the code. This interface will just provide two methods, one for converting an object to a JSON string, and in the other way around, converting a JSON string into an object. And let's check the tutorial of the Unity WebRTC package. These steps are not perfectly clear and may be confusing, so let's just keep it open and keep it as a reference for everything that will come when implementing all the stuff, as it gives a good overview. But first of all, let's check our signaling mechanism, and I'll choose WebSocket Sharp, as this provides a WebSocket implementation in .NET, which also supports Unity. And the documentation here on the GitHub page is pretty good for how to create a new WebSocket server. After downloading the zip of the GitHub repo, just open it in Visual Studio, click on Build Solution, and after the build is completed, you can just open the binary folder of the build. The path is in the documentation. Get the DLL and copy it into the plugins folder of your Unity project. I'll just create a folder for plugins and for the WebSocket Sharp DLL. And after everything is compiled, you can just leave the default settings and you'll be able to use WebSocket Sharp within your Unity project. So let's create a new script. Call it simple data channel server, and this script will be our WebSocket server. You can see the code here. There is a private WebSocket server, an IPv4 address in the server port. I'll just loop through all the addresses and create a new WebSocket server on my address and the server port and add a WebSocket server. We will do that in a minute, which will enable us to send messages to all connected clients. In the project view, right-click, create C# script. This will be our simple data channel service, and move that file into the services folder. And after opening, just derive from WebSocket behavior, implement the onMessage method, and make sure that whenever a message arrives at the WebSocket server, it is forwarded to all connected clients except the sender of the message. I guess I'll just leave a little comment here. And implement the onOpen method just to signal or to give an indicator when the client is connected to the WebSocket server. Maybe that's not right server, but data channel. Or maybe the simple data channel is better. Yes, that would make sense. So let's go back to Unity and create an empty game object where our server will be located. WebRTC data channel. Let's call it client server and add the simple data channel server object to it. So when having a server, we also will need a client. Let's create a new script for the client. I'll call it receiver, because this WebSocket client will also be the receiver of our peer-to-peer message, WebRTC message. I just implemented the basic WebSocket client code. And let's just add the simple data channel receiver here and check if our WebSocket client connects to WebSocket server. Click on play, and as the log message indicates, our client is now connected to the server and we are ready to send messages via WebRTC. As the documentation from the Unity package is not that good, I crawled through the internet to find a better documentation, and it's important to note that there is the Unity render streaming, which also uses Unity WebRTC here, but it uses a web server, we'll see that in a minute, a web application to do all the handling from the WebSocket and WebRTC stuff. We'll just skip that and keep all in Unity, so there is no need for web development or web dev. For further information about WebRTC, there is webrtc.org. Everything is explained here, how you can create peer connections, send data, or even send media like video or audio. And on webdev, the links are as always in the description box. There is a very good tutorial how to implement the WebRTC peer-to-peer connection. In this case, it's not the sender and the receiver, but Alice and Bob. And we will use Alice and Bob to implement our RTC peer connection. And we will just do that for the local area network, so there is no need for signaling, stun or turn servers. Please feel free to read on for this. And we'll first start with the receiving end, because we already started the receiver, and we'll start implementing it now. So first of all, we need a peer connection and a data channel. These two objects are the most essential part. We'll just have to create the connection and the data channel, and the receiver will be able to listen to messages sent on the data channel. And for this we need some kind of message receiving. I'll save that for the last part of this class, so we can just focus on the logic that the receiver will have to execute for successfully handling the messages. So first of all, we'll create the RTC peer connection, and the connection object has this onICE_candidate callback, which will create ICE candidate data whenever a peer connection is established, and will send this data to all the other peers. And for easier handling, I created a candidate init class. We'll create it in a second, which will transport this information over the network via a string, which is separated by an exclamation mark from the real candidate info data, and we'll convert this into JSON. And there is a debug log for the connection change and the data channel, which will receive the message when sent by the sender. So first of all, we need the candidate init class. We'll go back to our models folder, create a new C# script, call it candidate init, open the script and derive this class from the iJSON object with the type of candidate init. There are three public properties, and the two methods for converting from JSON into the class type and convert to a JSON string using the JSON utility provided by Unity. Again, feel free to pause the video and copy the code, and when we go back to the receiver code, we see that our candidate init class is now implemented and will handle or will hold all the data which is needed when candidates are created and sent over the network via WebSocket. Furthermore, we need to close the data channel and the connection when the game object is destroyed, in this case when the application is ending. And for the main part, let's check what our receiver has to do. So Alice creates an RTC peer connection. Alice sends serialized candidate data to Bob through whatever signal engine. This will do that when implement the sender, and when Bob gets a candidate message from Alice calls the add IC candidate, adding the candidate data and so on. Okay. Furthermore, let's check the detailed run. Alice runs the RTC peer connection, and so Alice creates an offer. sets the local description, and sends it to Bob. Bob sets the description Alice sent into the remote description for his connection, and Bob runs the create answer method, sets the remote description. So we have an offer and an answer, the offer from the sender side, the answer from the receiver side. And let's start implementing what should happen when Bob gets the offer. So there is a bool for has received offer and a session description which will be sent by the sender, and will implement this class the same way as we did with the candidate init. Into the models folder, create C# script session description. And again, we derive it from the iJSON object with a session type and the SDP, and we'll convert it to JSON, convert it from JSON for using to deliver the session description over the network. And we have to set this session description from our offer when we receive an offer from our sender. So let's check for this offer in the update method. So as soon as we receive the offer, we will create the answer and send everything back to Alice. And we will do that in a second. But first we have to handle the onMessage in the WebSocket. We will get a string and split it by the exclamation mark, where the first part of the string is the type of the message, either candidate, offer, or answer. And the second part is the data itself. So if the first thing is offer, we received an offer from the sender. Let's write the debug log and create the received offer session description from the JSON data we received and set the has received offer true, so that we can create the answer and send it back to the sender. And on the second phase, if that's a candidate message that is sent over the network, we'll just create the candidate data with the candidate init class from the data which was sent over the network. Create an RTC ICE candidate init object, set the values from our data, create the RTC ICE candidate object, and add this candidate to the current connection. If there is any other message, we'll just debug log it, and as you can see here on the onICE candidate callback from the connection, we will just send our own candidate data after setting them. So and if we got any other message, we'll just simply log it to the client, to the console. Now it's time to create the answer after receiving the offer. And in our description, in point 5, Bob creates the answer and passes the remote description he got from the sender. So a local session can be generated, and Bob sets the local description. So insert and create answer method. This has to be async, and from the offer we received from Alice, we will just create a new RTC session description, set the type to offer, and the description to the data we got, which is triggered when receiving the offer. So now we know who our sender is. We just set the remote description, and after the remote description is set, Bob runs the create answer, passing it the remote description he got from Alice. So a local session can be generated that is compatible with hers. Okay. And then the create answer callback is called. So we'll set the remote description. After that is finished, we create the answer. Let's check remote description. Yes, that looks good. And create answer callback is passed. Sets the local description and sends it to Alice. Okay, we have our answer now. Getting the answer description. Set our own local description from the connection. Create a new session description for sending it to the sender, in this case Alice, and then send it with the answer classification to the server, which will forward this to the sender. And the sender will look quite similar. Let's just clean up a little bit. We don't need these two usings here. Save it, and that's our receiver. And now let's create our sender, the simple data channel sender. And the basic implementation looks like the receiver. So we have an init client which will connect to a WebSocket server. And we'll also have to create the peer connection, the on-IC candidate, and we have to now send all the data to our receiver and create the offer as soon as there is a WebRTC connection to be established. And when Alice gets the answer from Bob, she will set her own remote description to successfully establish the WebRTC connection. Again, we have our connection and our data channel object, and we'll just create it similar to the receiver. New RTC peer connection on IC candidate generated. We'll just send the candidate data to all other peers via the candidate init object, which will be converted to JSON. So far so good. It's basically the same, separated by an exclamation mark. The connection state will be logged to the console. And the difference here is that we're not connecting to a data channel, we're creating a data channel, and we're just logging the onOpen and onClose method. And the onNegotiation needed callback will just tell us, okay, there is another peer, we'll have to create an offer to establish a connection to the other peer, which will then be sent to the receiver. And on the other hand, the data channel on the receiver side is only for handling the messages. So this is only one direction which can send messages. So again, we need something to handle the messages. This will look very similar to the receiver. We'll implement it later on. First of all, we have to take care of what happens if we receive an answer from the receiver. And again, creating a session description, this will look very similar. First of all, we have to check if there is an answer we received. And after the answer is received, we will have to set a remote description, and we can send a message via the WebRTC channel just by clicking the checkbox in the inspector. Again, on this try, we have to close the data channel and the connection. So far, so good. And let's check how to create the offer. So when creating the offer, we have to additionally set the local session description of our sender. Set local description, sends the session description to Bob. Then we have to send it. And it will not start getting candidates until the local description is set. Yeah, that's right. And if we have a look now at the Unity documentation, we will see that this is a very similar approach here, although it's not that intuitive as with Alice and Bob. So let's start by creating the offer. So first of all, connection.create offer. We're creating the offer, and from the offer description, we can create the set local description, and this local description will be used to send to the receiver. So this will be our offer. We created a local description, we offer it to the receiver so he can send it to his remote description. Okay, again, create offer. We are setting our local description and send it through the signaling channel, which is our WebSocket connection. Okay, that looks good. We're sending the offer. The receiver will handle the offer, create an answer, and send us the answer back. So we'll just have to wait until the answer is created and use the answer data on the sender side for creating the remote description for the peer connection. So let's do this first. Set the remote description. We're just using the data we received from the WebSocket channel. Create a new RTC session description and set our own remote description for the peer connection. And the only thing that's left now is how to handle our receiving messages. This will basically work the same. We'll request a string, split it by exclamation mark, and when receiving the answer, we'll just create this session description from the JSON data, has received the answer to true, to set the remote description, and when receiving the candidate data, we'll just set the ICE candidates basically the same way as on the receiver side. For our connection with the RTC IC candidate in it, create the candidate, add the candidate to the connection, and whatever other message will arrive, we'll just print it to the console. Let's check, adding the sender here, moving the sender just one up, and this should basically work. So let's try it. Okay, there is a lot going on. Let's scroll up. Our WebSocket server has started. There is a lot going on with offering candidate data. We have an ID here for the first connection. We got the offer, DataChannel, got the answer, checking the connection. There's a second ID, checking, okay, and connected and completed. So the handling for our WebRTC connection worked. The sender opened the channel, the candidate data is exchanged. And let's see, by checking the checkbox, yes, we can send data from the sender to the receiver. And let's check if that's right. We have sender opened the channel. The receiver received the message on the data channel in the receiver class, and the sender class sends us this message, DataChannel.send test. Nice. So it works on the local machine now, but we also should test it over the local area network. And you can easily do it by just creating another empty game object. Let's call it WebRTC DataChannel client, and only add the receiver component. So our Unity application will be the server/sender, and the client will be, in this case, my Android phone in the same network for receiving the message. Make sure that only one receiver is active, because this is only a single peer-to-peer connection for multiple clients. I will very likely create another video. And let's make sure to add some kind of logging, add a text on UI, import text mesh pro, and call it the log canvas. Recenter the text. Make it big enough to hold all our logging data. And maybe we'll just reduce the text size to, I don't know, let's call it 20. Center it and give it a little outline so that's better visible in the skybox. 0.1 should be sufficient. And let's call create a logging class in a folder called utils, and within the folder let's create a new script called screen logger. Open it and implement the log message received callback to fill the text of our text box. Again, feel free to pause the video here to type off the code, create an empty game object, call it screen logger, and add the component to it, and fill the reference from the log text box with the text mesh pro text. Deactivate the client here just for checking if it's working. Click on play, and we'll see that checking completed, server open, channel connected, completed, that everything is working now from the server and the client side, and even sending the data is logged correctly on the display now. Just removing the default text as we don't need it. And let's try to build it. Go to File, Build Settings, and switch to the Android platform. Switch to Player Settings, and in Player you can, okay, we'll have to wait a second. Change the package name. I shortened mine so it's easier to find on the smartphone. Increase the minimum API level. Set the scripting backend to IL to CPP and the API compatibility level to .NET, and the RM64 as target architecture for Android. That should be it. Let's see, let it compile. Deactivate the client server object and only the receiver object, and save the scene and build it. After testing, I realized that my text is way too small to be read on an Android screen, which has a much higher resolution than the free aspect in the game window, so I'll just change it to full HD, the portrait mode, and check the text size. It's way too small, so we have to really increase the size. Let's see what would be a good fit. Yeah, I would say around 80 should do the trick. Save the scene, and yeah, the receiver is active, the client server is not active, and let's go to File, Build Settings, Build and Run. Build it directly to the smartphone. When the build is completed, make sure that you deactivate the client object here and the client server object is activated again, and deactivate the simple data sender and receiver to first establish the WebSocket connection and then try to create the WebRTC connection. And I guess I should show you what I'm doing on the smartphone. So I'm just starting up the screen copy, starting up Unity. So started up logging, tells me that everything went to right. The WebSocket server is running. Here is my screen copy from my Android smartphone. The application started there as well, and the WebRTC connection is now waiting for a negotiation from the server. Everything is connected to the WebSocket server now, and if I am done with adjusting the screens, I will just activate the simple data channel sender, and we see that the negotiation was successful, everything is connected. And if I now send the data via the checkbox to the Android phone, there should be an additional log message, and here it is. And that's our WebRTC connection over WebSockets, done purely in Unity, no web development needed. And if you liked the video and you want to see more of such tutorials like WebRTC Media, WebRTC multiple clients, and so on, give it a like, comment the video, subscribe to the channel, and I'll see you in the next video. Bye.